Hello everyone, this is Venkatesh. Welcome to Venkat's Tech Talk. This is the fourth part of software design pattern presentation. Earlier in the first three parts, we looked at what is design pattern, why we need to care about it, and what is the value of design pattern. And also we looked at the solid principles, five solid principles in detail. Okay, now it's time to look at the practical design pattern, like looking at the practical example of a design pattern. So as I already mentioned as part of wiki definition for design pattern, let us recap it. So design pattern is nothing but a reusable solution to the common design problem. Okay. Now let us look at what are all those common design problems. So we have many design problems and each of the design pattern will try to solve some kind of problem. So one of the common problem is communication between objects. So as I already mentioned, application is nothing but a lot of composition of multiple objects. A lot of objects together forms an application. So it is a very common requirement in many application. There is a communication between objects. So when we talk about this thing, let us know some basic terminologies. So a component which sends a notification or an information to another component is called a subject. And the other component which is interested in receiving the notification from subject is called an observer. And this process of communication is called as subscription. In other words, if you want to tell, observer subscribes to the subject and receives notification. Okay, so just hold on, because these concepts will be very abstract and raw in nature. If we don't look at the example, it will be a bit raw, but just follow it with me. You'll be able to understand once I explain a real application level example of these things. Okay, so and when it comes to designing the object to object communication, there are few design constraints, or we can say it as design requirements. So rules or requirements, however we want to say. Observer is a component which subscribes to the subject, and subject is a component which notifies the observer. This is the fundamental rule or design requirement. Second thing is, subject doesn't need to be aware of the observer. Means like subject and observer are loosely coupled. A component which notifies the observer doesn't need to be aware of what are all the observers or subscribe to the subject. So this is one of the very key design requirement. Just we need to keep in mind to understand how a particular design problem solves this design pattern solves this problem. Okay. And third thing is, there can be more than one observer interested in a subject. Means like more than one observer can subscribe to a subject, to a single subject. And another point is, observers can dynamically attach or detach to a subject. Means like at one point three observers are subscribed to a subject, and another point just only one observer is subscribing to the same subject. So these are all the common design constraints or requirements when it comes to designing a component to component communication. Okay, so it is very raw and abstract. Let us look at what it means in a practical example. Okay, let us look at an real-time example. We have a component called a bank transaction component. So this component takes care of a lot of bank transaction related operations. It can be like an amount, debiting an amount, crediting an amount, or many things. Just for an simplicity for our example, just to make a little scope it with the right thing, it handles three kind of transactions. On amount debited, whenever some amount is debited from the account, or whenever some amount is credited, or some overdraft amount reached, these are three kind of transactions this bank transaction component handles. Okay, and there are two other components in the system, which is a text message notifier and email message notifier. These two components are responsible for sending the notification to the end client, the bank customer, on certain transactional events. For example, a customer is interested to know whenever an amount is debited from his account, he wants to be immediately notified through a text message. So a customer prefers to receive a text notification, and few customers prefer to receive an email notification with a statement. So these components are responsible for notifying the end customer. So following the single responsibility principle, these components just take care of notifying the customer. So to notify the customer, these components need to know like the bank transaction details. Whenever some bank transaction happens, these components need to know about that. So for that reason, these components, which are called as observer, these two are subscribing to the subject, which is bank transaction. So bank transaction component is a subject here. Text message notifier and email message notifier are the observers, and they are connected to the subscription process. So on amount debited is the event they are interested in hearing from the bank transaction. So whenever an amount is debited, so through this event, text message notifier will receive the notification, and it will handle that event and do the appropriate action like notifying a customer or sending an email or whatsoever it needs to handle. So this is the practical example of the theoretical point I explained in the previous slide. So here, as I explained in the previous design requirement, bank transaction doesn't not require to know who are all the subscribers, because these subscribers can dynamically added or removed. At one stage, email notifier may unsubscribe from it and go out of scope, and a new observer can come in and subscribe to the overdraft reached event. And similarly, this text message notifier can attach or detach. So bank transaction technically during compile time or design time or doesn't need to know about all these observers. It should be loosely coupled. Okay, that is one requirement as I already mentioned. So this is a slide. So now see the component in the earlier slide, email message notifier is removed. Now credit rating updater is another component which is interested in overdraft reached events. So whenever it subscribes to the overdraft reached event, and it handles the update credit rating um, event method. So whenever a overdraft reached, it sends some kind of things to the update credit rating functionality. So further, if we look at dynamically at one point, some observer X, observer Y, all these new observers are subscribing to the event on the bank transaction. So this explains all the theoretical concepts I explained a couple of slides before, where more than one observer can attach to a subject or detach from subject, and subject doesn't need to know about all these observers. Observers can dynamically attach and detach. So that all these concepts are explained here in this thing. Okay. So now we looked at what is the common design problem, and we looked at the definition of this design problem, like what are all the rules or design constraints that we want to solve. And we looked at the practical example of looking at the bank transaction component to see what exactly we want to achieve. Okay, now let us look at the implementation, how to build a solution for this problem, what we need to do to build a solution for this whole thing. Or in other words, is there any pattern in software design pattern world to solve this one? Yes, exactly. This problem is solved through observer pattern. So observer pattern is the solution for this common design problems. Okay, fine. Now we know observer pattern is the thing. How to implement in .NET? Okay, how to do this thing in .NET? So you remember I frequently mentioned in earlier presentation that some of the design pattern implementation are exposed as a programming language features, where developer would be using without even aware of the deep concepts of the design pattern implementation. So in .NET world, C# event and delegates are the answer. So C# events and delegates provides the implementation of the observer pattern. So basically, so it means like we don't need to reinvent the wheel of implementing this thing. So everything is done for us. Once we start using event and delegate and expose these event and delegates on the subject and on the observer part, if we just subscribe it to through the event handlers, that's all it is, the implementation of the observer pattern. So it looks like pretty simple and two lines of code, but all we need to understand is the concept behind it. Okay, you hope you remember I told about how we can I'm going to help you on articulating the design pattern usage in the real-time perspective. For example, definitely I would confidently tell every programmer would have used different events and delegates in their code. It can be like this, like developing a component where that component exposes an event, where at the other end of the component we subscribe to that event and we handle this transaction. So if you have used this kind of thing in your code, it means you have used the observer pattern. But only thing is you may not be aware of this pattern as a definition and as what problem it is trying to solve and all those things. So now you need to remember all these things. So what is the design problem we have? Object to object communication. And what is the solution for? What are all the those design constraints or requirements that we need to address? So as all those points I mentioned. So what is the solution? So just we need to use event and delegate. So just you can put all these things together and you will be able to articulate the usage. So understand the concept and tell software in .NET we have events and delegates or the solution for the observer pattern. Once if you start using it, it means like you are providing an solution for an implementation of an observer pattern. That's it. So you can just connect all these dots and you can articulate with your real-time project example of wherever you have used events and delegates. Okay. So just in the code perspective, how this looks like is given here. So basically, the left side of this presentation talks about the subject. So this is the bank transaction component code. It has three delegates. As you already may aware, delegate is nothing but a function pointer. You can point to the function that matches with the signature. So amount debited is a delegate which takes an argument of integer and which returns a void. So that's it. So any observer can just take this event and assign to a method which follows this delegate signature. So we have an event that wraps this delegate. Amount debited is a delegate and we are exposing an event of the type which is on amount debited, on amount credited, on overdraft reached. So these three are events of this delegate with this function signature. And on the consumer side or on the observer side, this is a bank transaction instance. This instance may be obtained through a dependency inversion or injection principle. And on that, we are subscribing through the event handler on amount debited. Whenever an on amount debited is happening, we are just pointing the reference to a notify customer method. So this notify customer is a local method following the signature of this delegate, which is a debited amount of integer. And so whenever an amount debited happens within the subject, this method will be instantaneously called. So and we can handle what we want to do for those kind of events. Means like we can handle that and send the notification. So hope this explains the design problem, common design problem of the and the solution provided by the observer pattern. Okay, hope it helps. Thanks for watching this video. So in the further videos, we will look at the other design pattern implementation with .NET base class library and how it is used and kind of things. So thanks for watching. Um, if you haven't watched the other three parts, just go and watch it and you will have like a lot of information to learn about. And if you like these videos, just hit like and share your comments in the comment section below and subscribe to this channel. Have a great day. Thank you. Bye.